Okay, you're given this implicitly defined relation and has to find the slope of the curve at the point -2, -6. Now, what I've done here is taking it a little bit further than was suggested by the problem. Here's the original function, this red relation, this red curve. -2, -6 is confirmed to be on the curve. Here's the actual definition of y prime. So I could plug in any point that's on the curve to find the slope, and it looks like that's the slope. If you put -2 in for x, -6 in for y, that's what you get. And there's the equation of the tangent line at the point where x is -2 and y is -6 using point slope. Okay, now since your problem just asked for the slope, we want to end up with this number. You don't have to actually go to the trouble of isolating y prime. You can substitute after you've done the implicit differentiation. So how do you get from here to here? Again, we're taking the derivative. We're looking for the derivative of y with respect to x. So the derivative of 4x to the 6, simply the power rule, 24x to the 5th. Here we have to use the product rule. I think of -9x as the first function and y is the second function. So it's the derivative of the first function, -9 times the second function, y. And then the second half of the product rule is the first function, -9x, times the derivative of the second function. You could also call y prime dy dx. And finally, for 9y squared, 18 times y, but then you have to employ the chain rule, multiplied by the derivative of the inside. So there is what you get after implicit differentiation. All you have to do is plug in -2 for x, -6 for y, and then solve for y prime. And that's what I've done here. Once you get to here, the greatest common divisor of 7, 14, and 90 is 6. So you can divide numerator and denominator by 6. There's the slope. Okay, hope that helped. If you have any questions, post a comment.